Hello and welcome to today's video lectures on data structures and algorithm. The topic which I am going to take is on recursion. In computer science, you will see that many topics are found to be puzzling and abstract, and recursion is one such topic. In computer science, besides this, the recursion has been a bit controversial topic. In computer science community, there are three groups, and all these groups have a different opinions about the recursion. One group thinks that recursion is a solution for all set of problems. There is another group which think that recursion is a solution for only one set of problems. Then there is a third group which think, and in fact they have developed the antipathy towards the recursion, and they always try to create the recursion with inefficiency. That is why, which I think that the most widely spread programming language for scientific use, that is a Fortran, still forbids the use of subroutine for recursive purpose. And because of this, they are not able to solve certain set of problems for which recursion is the ideal situations. Now, through this video lectures, I will try to talk about where to use recursion, where not to use recursion, what is the recursion, of course, and then finally I will try to illustrate one small example at how to apply the recursive programming constructs through C programming language. Now, so this is basically four topics we have organized. What is the recursion? I will start with what is recursion, when to use the recursion, when not to use recursion, and finally illustrate programming through certain programming language. But let's have a small definitions to start with. A program is said to be recursive if it partially consists of or is defined through itself. For example, you all have been writing a small program, and you all have been calling some function through some function. For example, you have been writing a program in which a function A calls function B calls function C. But think of a situation where function A calls itself, or function B calls itself, or function C calls itself. But each time, of course, a different set of values, and that is an example of a recursion. And I will give you various other examples which not only in mathematics and data structure, but in our day-to-day activities also, which we come through recursion. But let's have example. So recursion will be a particularly very powerful means. Either you work with a data structure or a mathematics, recursion will be used quite often. So it's a very powerful tool for writing a programs in data structure or solving certain set of problems. So we, as I told you earlier, that recursion is also encountered in day-to-day activities. Everybody has seen the advertising picture, and you must think of it that this picture contains itself. So this is one small example which we come across all the time our day-to-day activities. Let's have a small example which you have seen from school days, that is a natural number. For example, 1 is a natural number. Now, successor of any natural number is also a natural number. For example, 2 is a natural number, 3 is a natural number. So each natural number is defined through another natural number. This is what we are talking about, that any number which is defined through itself, that is a natural number, and that is a recursion. Let's see another tree now. Now in tree, what you have is, let's see this is a big tree. Sometimes in computer science we call it a binary tree, because maximum it has got 2 branches. This is one branch, this is the second branch. Now this whole tree can be defined through one subtree. I will call them left subtree, and this one it can be defined through another subtree. Let's call it right subtree. Now this tree can be defined further by this left tree which has got only one node. This can be defined through another right subtree which has also got one node. So basically, all the time the emphasis is that if something is defined through itself, and that is the recursion. This big tree can be defined through smaller trees, one left subtree, another left subtree, which can be further defined by another left subtree, another right subtree. And you will see that lots of problems can be solved through this type of data structure called the tree. Let's go to the third example, factorial problem. Now, factorial is a very good example to understand that what is a recursion. Take example of factorial of 5, for example. Now, factorial of 5 can be defined through factorial of 4. Factorial of 4 can be defined through factorial of 3, and so on. So what we are talking about is the factorial of n factorial of n can be defined through factorial of n minus 1. Factorial of n minus 1, just in this case, that the factorial of n can be defined through factorial of n minus 1. Factorial of n minus 1 can be defined through n minus 2. So same thing, if something is defined through itself, and that is the recursion. Let's go to now let's try to find out, conceptualize what we already discussed. Recursive algorithms are primarily used when problems are to be solved, the functions to be computed, and the data structure to be processed is defined recursively. Now again, if you recall what we are talking about, that if all these things, any problem, any functions, any data structure is defined through itself, that is basically good candidate for applying recursive technique. Now, any programming language, like for example, take example of C, Pascal, with a new programming language called Java. All these programming languages define recursion. They provide a certain tools to define the recursion, and they have basically defined only these tools. Either you can, so basically to define a recursion, either they must be providing a procedure or a subroutine or a function. Like for example, in C language, if you want to have a functions, if you want to have a recursive applications, you want to use recursive applications, then you have to use a function, right? So this is the way we start writing a program. And now what I told you earlier is that when to use, okay, before coming to when not to use recursions, let's have what type of recursions we come across. The example which I have been giving you, that function A calls itself or function B calls itself, it is an example of a direct recursion. But we have another type of example, what we call an indirect recursion. In this case, what happens is that if a function A calls function B, if function B calls function A, that is the example of indirect recursion. And when you start solving all these problems in data structure, you will be using both type of recursive techniques, but mostly you will be using a direct recursion. Now, I told you in the beginning that where to use recursion. I told you that what we are talking about is that if you have, this is what, let's say, try to conceptualize here. This is what I told you in the beginning, that if you try to use a recursion, then it has to be, problem has to be defined, the function has to be computed, or data structure has to be defined, everything has to be defined through recursion. Now, let's try to understand then when not to use recursion. That is an important thing to understand before using this one. Now, always avoid to use a recursion when there is no obvious solutions by iterations. If certain problem can be solved by iteration by using for loop or while loop, you know that any programming language, C or Pascal, they all provide you iterative construct, for example, for statement, while statement, and so on. So if any problem can be solved through iterations, for example, factorial can be solved, Fibonacci series can be solved, then better not to use recursion. Why? This is the reason. Let me explain you why. Because if you try to solve a Fibonacci series, you know that Fibonacci series, each next number is obtained by adding to previous number. So computations of the Fibonacci series, if you use a recursion, although it is defined recursively, but it can be solved directly through iteration, right? So if you use a recursive technique for Fibonacci series, you will be making exponential growth of the calls. So we always try to avoid this type of situation. What exactly we mean by exponential growth? This is a diagram which we will be able to explain to you. Just in this case, if I want to solve a Fibonacci n, in this example n is 5, just you imagine that how many calls I have made. And one more important thing to understand how recursive program works, which is not explicit when you start writing a program, that behind the scene, in the background, a data structure called a stack is created. So all the time you make a call, the intermediate results are stored into this data structure. Just in this case, I wanted to find out the Fibonacci series of number 5. Right? So now this, if you have a 5, then it calls 4 and 3, 4 will call another 3 and 2, 3 will call another 2 and 1, this 3 will call another 2 and 1, and so on. So to generate a number 5 Fibonacci sequence, you are making 15 calls, so your stack will be quite lengthy. So length of stack will increase. But if you take example of only 20 or 30, just imagine that you are making the exponential growth of your stack. So the programs becomes much slower. So you have to understand when to use recursion, when not to use recursion, and that is one important thing, that if something can be solved iteratively, like Fibonacci, factorial, always define, don't use recursion. Always one has to understand this thing very well. Okay, but I told you that the recursion is not only used for solving mathematical problems or what we call them data structure problem, but it can also be used for generating a very interesting graphic patterns. I will give you one or two examples of a graphic patterns. One graphic is what we call them the Hilbert curves, just in this case. And any complicated Hilbert curves graphics can be generated. So this is very interesting application of a recursion. Now just in this case, this has been named after D. Hilbert, who had designed this type of things. Now just in this case here, what I am trying to explain to you is that any complicated graphics has a recursive application. Just in this case, if you try to notice this is called order of 1, this is order of 2, and this is order of 3. So if I want to generate a Hilbert graph of order 3, what I am trying to do, not all the time I am computing new thing, I am simply trying to superimpose the graph generated at the order of 2. So just see that simply how I am trying to get, I am simply superimposing one and combining with each one. So this graph has got by combining this one and this one, and any number of order you can simply generate, you can by simply combining the previous orders of this graph. So and people always use this type of things in the fashions designing to create a different type of patterns. This have another interesting example. Just in this case, that this is another called Sierpinski curve. I have just shown you of only one order or two orders. Yeah, but this, again, just like the previous one, I can generate very complicated graphics using this one. So the job will be simply to superimpose one over other. And this is an example of a recursion, because a big pattern is being defined through a smaller pattern. So just you notice one thing, that the recursion has got a very important role in the graphic side also, not only in mathematics and the data structure, but somewhere else also. Let's try to be more precise that where we are going to use a recursion, and we are giving you 2-3 areas where I think the recursion can be used quite often. And one such area is what we have what we call them dynamic data structure. When you go further, like 3 things I have defined here. Okay, the binary tree, AVL tree, and B tree. This is something we are not going to discuss about, but as we proceed further in data structure course, and this problem cannot be solved with iteration. You will see that you try as an exercise, try to write through iteration, you will see that the program will be much more lengthier, and also it will be very much readable. But this is a very good candidate for writing recursive application. So one type of application is what we call them dynamic data structure. The another is what we call them sorting algorithm. For example, we have the quick sort algorithms that can be easily written through the recursion. There is another set of problems, what we call them Tower of Hanoi problem. So these are very good candidates for writing recursive application. But as we proceed, we will be talking about how to use recursive applications in data structure. Let's have the now let's come to coming to the actual program writing. What you have to be concerned about, what are the basic smaller guidelines one has to be follow. We have 2 or 3 important things you have to always consider when you are writing a program using recursion, using any programming language. So for example, you must have a terminating condition. There must be, just like for example, when you write a program through iterations, the loop has to be terminated. Your loop should not be infinite, it has to be terminated. Same way, when you are making calls to itself, same function with using a different values, it has to be it must have some terminating condition. And through program I will show you what is a terminating condition, how to incorporate terminating condition. The second will be, that is very much important, each time you make a call, you always have to come nearer to one step nearer to the solutions now. So each time when you pass a parameter, you see that your solution should be nearer to actual computations now. And the third one, already you see, which I was trying to explain you when we have a I was trying to write a Fibonacci series. I was trying to explain a Fibonacci series with n value equals 5. Now in this case what we have is that the smaller size of the stack. Now the size should be very smaller. What exactly mean by size should be very smaller means that the number of calls should be very smaller. Just if you remember, with n5 the calls you have made is called 15, right? So this calls should be not very high, otherwise the size of the stack will be very high. I told you that behind the scene, to understand how does a recursion program, one has to conceptualize how does a stack work. So if the size is very high, your length of a stack will also increase, and then in that case the program will be very, very slow. Now, so once we have the three things are defined, now time has come to write a small program to demonstrate how to write a recursive application. Although I told you that this is the program is same called Fibonacci series. Although it is not a very good candidate for writing a recursive program, but it's very easy to understand how to write a recursive program. So just for sake of simplicity, I have taken this example. But again, the size should be, the n value of n is very small. Now what this program is, that it generates a Fibonacci series. And Fibonacci series is that each next number is obtained by adding two previous numbers. Now let's try to see this program is written into C language. We're not going to details of this whole syntax because you must be aware of it, that if you write any C language program, you must have to declare the important library from where the function has to be used. Like for example, stdio.h in C, there is in C compiler there is a library which deals with the handling of I/O devices. So there is two functions we have used, scanf and printf. Both are related to the I/O functions, and the whole logic is defined into stdio. Now the main any program in C language is start with the main function. Main function is a function which takes a control from the operating system, passes the controls back to your program, and when your program is terminated, the call is passed back to the operating system. So main function has to be used. And so in this program we have one function called main function. The job of the main function is to take the parameter for which you want to calculate the Fibonacci series. In this case this is n, right, and this is the syntax. We have ampersand n. So you can input the value of n, 1, 2, 3, 4, 5, whatever number you want to take, right, and then simply I am calling the function which will calculate the Fibonacci series. Now one thing you always remember, that any programming language must provide certain tool to write a recursive applications, right? For example, in C language, all the recursive programs can be written through a function, right? So if you want to map them, your application, recursive applications, you want to map them into programming language notation, the use of function is must. So I am calling a function called fib and passing the parameter n. Now once I pass the parameter of n, so I have to call this function. Now once I call this function, so what is the name of the function? The name of function is fib with value n. Now here I am calling this function fib now, right? I am passing the value of n. N depends upon you what you want, 1, 2, 3, 4, any number you can pass. Now this is the function. Just see one thing, just try to notice one thing, that what is the recursion here? I told you in the beginning that if anything can be defined through itself, if function calls or if function call itself, but each time with different parameters, that is a recursion, or that is a recursive program. So in this case, there is a function called fib, and then I am calling the same function here. If you see when I have written the last statement, else return fib n minus 1 plus fib n minus 2. The same function I am calling, but each time the value of the parameters will be different. For example, if n is 5, then so try to understand how this program really works. Okay, I have shown you the same. I will take you to the same diagram which I have taken you earlier. So how this program works, I have tried to explain you here again. But that diagram I will explain through in a different context. But this can also be used to explain how the recursive program works now. So I am passing the value of n, that is a 5. 5 will call 4 and 3. 4 will call 3 and 2, and so on. Let's go back to the program, what this program is telling you. In this case, what will happen? First time n is 5, then the function same fib will be called with 4 and 3. When n becomes 4, then it will call then 3 and 2 and so on. So each time I am calling the same function. So there are 3 things you have to understand. First you have to define a function, pass a parameter keeps on changing, same function should be called but each time with a different parameter. And one thing I forgot to tell you, that what is the important thing, the terminating condition has to be there. If there is no terminating condition, that will be going to the infinite loop. My stack size will be very high, program will be very much slower. So the first thing what you have to do whenever you write a recursive program, you must notice one thing, that terminating condition has to be defined. Either you write a factorial, or you write a Fibonacci series, or you write any data structure based program, terminating condition has to be there. And what is the terminating condition is this, that if n is equal to 0 or n is equal to 1, then it has to return n, otherwise its function will keep on calling with the different parameters 5, 4, 3, 4, 3, 2. So again go back to my previous program, but first 5, then we call same function with 2 different parameters recursively. Then when 4 comes, then it will call 3 and same function fib with 3 and 2 parameters. When comes 3, then it will call same function with 2 and 1. Just notice one thing, that each time I am changing my parameter, and at each call I am coming nearer to the solution. But moment I have a value 1 and 0, 1 and 0, this is the terminating condition, and finally 1, 1, 1 will be added to it, and the result will be stored. Let's go back to the program once again. This is what happens. So this is my terminating condition. This is my last node in the branch, right? Beyond that I can't go. This is once again go back. You see, this is 1 and 0. This is my terminating condition. Beyond that we are not making any recursive call. But when we have a 4, 3, when we have a 3, 2, calls are being made. Same function is being called but different parameters. So let me summarize. 2 things are important: terminating conditions and calling, defining recursion through your functions. Depending upon which language you are using, you have to use a syntax, but each time parameter has to be changed. So this is one small example of recursion. Let me summarize once again what we have discussed now. 3 things I told you in the beginning, that recursion is a very powerful tool for solving all sort of problems. We have a data structure problem, tree, dynamic data structure can be easily solved through recursions. And the second thing what I told you, that it's a very challenging and exciting problem. Very complicated graphics patterns are easily generated with recursion. Your job will be to discover, to explore what is a recursive thing, and simply you keep on calling the function with these different parameters. And the last thing which I want to emphasize is that any problem which you have written through iterations can be solved through recursion also. But you have to be very, very careful that certain problem which can be written through iteration, you better write through iteration. Otherwise, the number of calls will be very high, the size of stack will be very high, and finally your program will be very much slow. So I think you have understood where to use and where not to use recursive type of program. This way I am coming to end. Thank you very much.